And now the last part of our Big Bang and waves test, we're going to be focusing on waves. So first, we're given this kind of normal looking wave. We call this a sine wave, and asked to label the parts. This was kind of straight out of our notes. So let's check these off. The crest. The crest is the high point of a wave. So we've got a crest here. We could identify another crest just to be thorough. A trough is the low point of a wave. So here we have a trough. And here we have a trough. Now it's asking us for the wavelength. Well, the wavelength is defined as the distance between two crests or two troughs. So if we mark this as a wavelength, and then lastly, it asks for amplitude. Amplitude is defined as the distance from kind of the zero line of this graph, which is, or of this wave, which is right here going through the middle. That's kind of the normal line. And saying what is its height from that line. And it could vary if this was, but this is a very consistent one that we're looking at. So we could say that the distance from that zero line to the crest is the amplitude. Done. Now we'll keep looking at this wave for a moment because number 10 asks us a second question about it, saying if it took 1 second to produce this wave, what is the frequency? Okay, so the frequency is the number of wavelengths that go by in 1 second. So we just need to count wavelengths here. Well, we have one wavelength that we have already labeled. And clearly we have a second wavelength going to this other crest here. So we can see that we have two wavelengths. However, let's not ignore the fact that we also have this part right here and this little part in the beginning. So if we scooted this whole thing over, what we would find is that this actually goes up to another crest. So if we started it here, it would finish here. And so we have a third wavelength. So 1, 2, 3 wavelengths per second. So our frequency is 3. All right, 3 wavelengths in 1 second. All right. Lastly, we need to know our equations here. So our if a wave has a wavelength of 2 meters and a frequency of 100, call this hertz or cycles per second, what is the speed? So it's asking us for speed. Another fancy word for that is velocity. So velocity is question mark. Our wavelength is 2 meters, and our frequency is 100 inverse seconds. So we can now work that out. Now that we know what is given to us, let's take our equations and figure out which one is going to give us what we need. So we've got 3 different versions of the same equation. The one that works best for us is velocity equals frequency times wavelength. So I can simply take velocity equals frequency, 100. And we can say that's 1 over second. That's what second to the minus 1 means. And multiply that times the wavelength, which is 2 meters. Multiply the numbers. 2 times 100 equals 200. Multiply the variables, meters over second. 200 meters per second is the velocity. All right. Last thing, we just need to reflect on this. Oh boy, this sure was easy this time because studying makes tests easy. Awesome. Thank you guys. Good luck on the retake. Make sure that, especially for a question like number 10, that you are careful to look at how many seconds it takes. And for a question like number 11, write down the variables that you're given. Write down what you're being asked for. This is the way that we would arrange it if we were looking for velocity. If we were looking for frequency, we would arrange it F equals V over wavelength. And if we were looking for wavelength, we'd say that lambda equals V over F. They all say the same thing, they're just arranged differently, just a little algebra. So make sure you use the one that is going to help you solve for the unknown variable the easiest. All right, thank you, good luck.